Hello everyone, today we're going to be doing Unit 7, Lesson 7, which is solving exponentials. There's going to be two different methods, so this video is going to be method 1, the next video will be method 2. You can choose whatever method you prefer the most, you just need to make sure that you can do one of those two methods correctly. Okay, so skipping the warm-up, that's just making sure you can do what we did the other day. With method 1, you need to make sure that you're isolating the exponential expression. That means that you need to have whatever is being raised to the exponent by itself before you can do anything else. Okay, so step 1, what we're going to do is we're going to take our 2 to the x is equal to 61. The reason we can't do this like we did in the previous lesson is because I cannot rewrite 61 as 2 to an exponent. So that means there needs to be some other way that you can do this. So using method 1, we're going to rewrite this as a logarithm. So to rewrite this as a logarithm, this will become log base 2 of, so remember your 2 and your 61 are the big numbers, so they'll go on the same side. So you get log base 2 of 61 is equal to x. I now can plug this into my calculator, so you'll need the TI-84, okay? And to find your log base, remember you hit alpha window, and I want number 5, and I want log base 2 of 61. And then here's my answer. Since it has, oops, what did that happen? So I forgot to arrow over and I didn't get the right answer. So I got log base 5, 2, arrow to the right, 61. Here we go. You're going to get a long decimal. So we're going to say x is approximately 5.9307. Okay. So you need to make sure that you're rounding your decimal to the nearest 10,000ths place, which is 4 decimal places. So you always round it to 4. What we need to do though is we need to make sure that this answer does in fact work. Okay. So to check your answer, we're going to plug it back into the original question. Here's kind of a shortcut. Since that's a long decimal, if I were to plug it back in, sometimes rounding will change the answer. So if you do second raised to the second negative sign, it'll plug the answer in that I just got, and it does get me back to 61. So once again, to get that answer, I did 2 raised to second. I can't do answer now because it's not going to work, but that's how you get that to show up, and then you want it to equal the original number that we had. Okay, and that's how you do number 1. So number 1, my answer did work, and that would be my final one. Okay, so let's try number 4. Oh, that's number 3, by the way. Here's number 4. Okay, so we have 8m minus 7 is equal to 92. My 8 is already by itself, so I can rewrite this. I'm going to say this is log base 8 of 92 is equal to m minus 7. I'm trying to solve and get this m by itself. So to get rid of that minus 7, I'm going to add 7. Now here's the tricky part. Okay, your 7 is not part of that logarithm. So you're going to have log base 8 of 92, and then you're going to have your plus 7 on the outside. So when you go to plug that in, you need to make sure that you don't put your plus 7 inside of your logarithm. So now let's go through and check our answer. Okay, so going back to the calculator, I'm going to hit alpha window, number 5. I want log base 8 of 92. Make you arrow outside of your parenthesis and you'll hit plus 7. And here's my final answer. M is approximately 9.1745. Okay, so once again, you need to plug this back into your original equation. So you're going to do 8 raised to second answer minus 7. And we need to make sure that this is equal to 92, which in fact is 92. So this answer also works. Okay, let's try another one. So on number 5, you probably should see my work before I move on. Okay, for number 5, we have 4 times 7 to the n is equal to 148. I need my exponential part to be by itself. That means you got to get rid of this 4 that's being multiplied. To get rid of that 4 that's being multiplied, you do the opposite, which is division. And you'll get 7 to the n is equal to 37. Now that I have my exponential by itself, you can rewrite this. This will be log base 7 of 37 is equal to n. Plug it into our calculator. Once again, alpha window number 5. We have log base 7, arrow to the right of, it's down to the right, 37. And that's going to equal approximately 1.8556. Okay, we need to plug this in to make sure that it works. We have 4 times 7 raised to the second answer. And we need this to equal 148, which it does. So once again, final answer works. Okay, so I think you get the idea of that. Let's flip to the next page and try some that have a little bit more steps involved. Okay, so if we were to look at number 7, we have 7 minus 4 to the x plus 1 is equal to 18. I need to get this 4 that's being raised to the x plus 1 by itself. So to get rid of this positive 7, I'm going to subtract 7. And you get negative 4 to the x plus 1 is equal to, what is that, 11. I need this to still be a positive because you can't take a log of a negative. So we're going to divide everything by negative 1, and you're going to get 4 to the x plus 1 is equal to negative 11. Okay, when we go to rewrite this, you're going to get log base 4 of negative 11 equals x plus 1. But this is the part you need to be careful about, because can you take the log of a negative number? The answer in that case is no, so this one has to be a no solution. So make sure you're careful with that as you keep working. Okay, let's try number 9. So for number 9, we have 4 times 3 to the n plus 15 is equal to 359. Step 1, I need to get whatever has an exponent by itself, which would be 3 to the n. That 4 is going to be attached with it for now. So we need to get rid of that positive 15 by subtracting 15. And you're going to get 4 times 3 to the n is equal to 344. I still need to get 3 to the n by itself, so I'm going to divide both sides by 4. I'm going to get 3 to the n is equal to 86. I now can rewrite this and get log base 3 of 86 is equal to n. And then I need to plug this into my calculator to make sure that it does work. So go to my calculator. We're going to do alpha window number 5. We have log base, maybe, computer's really slow today. Log base 3 of 86. And I'm going to get n as approximately 4.0545. Okay, and then we got to plug this in to make sure that it works. We're going to do 4 times 3 raised to second answer, arrow to the right, and then we'll do plus 15. And I got 359, which is what my original question asked for. Okay, let's try 1 or 2 more, make sure that it works. Here's number 11. Let me switch screens. I'm going to have 5 times 9 to the v minus 1 plus 1 is equal to 181. Once again, you have to get whatever's being raised to the exponent by itself first. I'm going to get rid of my positive 1 by subtracting 1. You get 5 times 9 to the v minus 1 is equal to 180. I need to get the 9 by itself, so I'm going to get rid of a multiplied of 5 by doing division of 5. And I have 9 to the v minus 1 is equal to 36. Now that my 9 is by itself, you can rewrite this in log form. I'm going to get log base 9 of 36 is equal to v minus 1. And then to get the v by itself, to get rid of a minus 1, we're going to add 1. But that plus 1 is not part of my logarithm, so you need to make sure that when you plug it in, it's outside of this. Okay, so when I go to plug this into my calculator, alpha window number 5, we have log base 9 of 36, arrow to the right, and then we'll do plus 1. So once again, that plus 1 is outside of that parenthesis, and you'll get an answer of 2.6309. We need to plug this in to make sure that it works. So we can do 5 times 9 raised to the second answer minus 1, arrow to the right, and then plus 1, and that needs to equal 181, which it does. So here is my final answer. Okay, so on the last one that I'm going to do, I'm going to show you how to plug it in case your calculator is not the TI-84. It's not any different in terms of solving, it's just your plugging in is slightly varied because you can't do your log base. Okay, so when you go to start on this one, you still need to get whatever has your exponent by itself. So we're going to get rid of a minus 2 by adding 2 to both sides. And you got 6 times 16 to the 7y plus 2 is equal to 84. So nothing different there. I need to get the 16 by itself. In order to do that, I'm going to divide by 6. You got 16 to the 7y plus 2 is equal to 14. Since your 16 that's being raised to the exponents by itself, you can rewrite this. You get log base 16 of 14 is equal to 7y plus 2. Okay, so now we need to get the 7y by itself. To get rid of a positive 2, I'm going to subtract 2. You get log base 16 of 14 minus 2 is equal to 7y. And then last but not least, we need to divide everything by 7. And you're going to say y equals log base 16 of 14 minus 2 all over 7. Okay, so to plug this in, depending on the calculator that you have, is a little bit more work. I'm going to show you how to plug it in if you were to have a TI-83 graphing calculator. So your TI-83 graphing calculator does not have the log base button. So what you're going to do for step 1 is you're going to do log 14. Oops, that's 114. I want log 14 divided by log 16. So remember, this is your change of base formula that you don't have to memorize. It just depends on the calculator that you have. So I'm going to hit enter. I'm then going to do my minus 2, enter, and then I'll do the division of 7. And you're going to get a y value of negative 0.1497. Now, if you do have the log base, then you can plug it in as a fraction, and I would do alpha x or alpha y equals to get the fraction button. And then I'll do alpha window 5. I got log base 16 of 14, arrow to the right, and then I'll do minus 2, that's a plus, minus 2, and then I'll arrow to the bottom and have my 7. And I'll get the exact same answer as if I were to do it the longer way. So regardless, that's how you can solve using method 1. I think it is a little bit easier than method 2. So see how you like this one so far, and then we'll get to method 2 in the next video.